Welcome everybody for another CSOC webinar. This is the last one of 2025. I'm Jenny Tipler and together with Julio Ortiz, we'll be hosting this webinar. Today we've got something a little bit different for you. You're going to hear from practicing engineers about a particular project they've delivered. I'm happy to introduce Julian Ramsey and Thomas Richards from Ruamoko Solutions as our presenters. Julian is Managing Director and co-founder of Ruamoko Solutions. Structural engineer at heart, he's led award-winning projects and recently launched Ruamoko Innovation for space and defence solutions. And Julian was the project director on this court theatre project. Thomas is a senior engineer who's been with Ruamoko for over 10 years. He led the court theatre project from conception to construction and loves tackling challenges. Outside work, he is a competitive distance runner. So welcome, Julian and Thomas.
Thanks, Jenny. All right. So I'm just going to make a start here. Basically, I'll be talking for about a quarter of an hour, talking about the sort of history and background of Ruamoko Solutions, how we ended up on the court theatre project, and a bit of what we're about. Perhaps a bit of a shameless plug, if you will. And then Thomas is going to take over and talk about some of the more technical parts of the court theatre project. So Ruamoko was established in 2006. We are Christchurch based predominantly, but we do work all over the globe and in fact in every continent. Our company name is named after the Māori god of earthquakes and volcanoes, and we're very proud of that name, which we've had since before the Christchurch earthquakes, obviously. 4 years prior, everyone thinks we jumped on the bandwagon a wee bit, but in fact we didn't, and we were privileged to get our name accepted by the Maori Language Authority and trademarked, which has been really good. We specialise in seismic solutions particularly, and like to be on the innovative side of things, for which we've picked up a number of industry awards. We've built about $3.5 billion worth of, engineered about $3.5 billion worth of built work over our 20-year history, or 19 years, coming up 20 next year. And as I mentioned, about 60% of our work is in Canterbury, with about 20 or 15% being in the wider New Zealand region and 20 to 25 being offshore under the Ruamoko Innovation umbrella. We are client-based rather than project-based, which is to say we're not ruthlessly commercial all the time. We sort of value developing relationships, and we're medium-sized, which means we're sort of small enough to care but big enough to matter. We're slightly unusual in that our revenue ratio, or our project size to revenue ratio, is actually larger than most firms. So for our medium size, we work on projects sort of $50 to $100 million with no issue, which can result in being a fairly spiky workload, but with careful management, we enjoy working on a large range of projects up to the fairly large. We have 20 locally based staff in our Christchurch office. Cameron McPherson and myself are the directors, with Sophie and Ewing in the senior management group as well. And Thomas is a senior engineer on the team, and he was the sort of day-to-day contact on the court theatre project, and handled most of the day-to-day runnings of the project. And I was project director. Our company values are people, passion, results, particularly in that order. You get results from having passionate people, basically, and we enjoy sort of a work hard, play hard culture. We work on theatres, halls, auditoriums, space and tech sector, pretty much any structural project we like to get involved with. Right, high-end res is a bit of a market for us. New seismic technologies. Obviously, we do the bread and butter, the warehouses, the supermarkets, retail, right up to multi-story apartments and large entertainment facilities and the like, as well as strengthening and so forth. Just a bit of a background on some of the projects that we've recently been working on. So these are all around New Zealand and some overseas as well. So a bit of high-end res in Auckland in the middle there. The Papaho facility for the Kind Foundation in Christchurch is on the top right. Opuki Thermal Pools and Resort, that's in Methven on the bottom right. We've strengthened the public trust building. A few of you from Christchurch might know the bar on top, Mr. Brightside. There's Ballantyne's building on the left, which has got a seismic joint right in the middle of it, as you can see. Flock Hill Lodge, which is a sort of $18,000 a night special, which is lodged in the Arthur's Pass region. There's a bit of high-end res. We do a lot of work for Patterson's Architects, based in Auckland. The school building on the bottom right, that's Redcliffe School in Christchurch. Building in the centre is a typical office building in Christchurch that was rebuilt. That was part of the rebuild. Surf Lifesaving Club, New Brighton, top left. 335 Lincoln Road is a building that we won an award for. It was the first building in New Zealand and possibly the world to use replaceable link EBFs, which we worked very closely with HERA and SCNZ on, who ultimately ended up developing guidelines, which most of you are probably familiar with. Bottom right, that's New Zealand Blood. A couple of quirky and weird houses. There's one on the left, and a church, St Mary's Church, built after the quakes, centre at the bottom. There's Flock Hill Lodge on the top left, suspended concrete chimney, that was fun. Lighting towers, that's a Hagley Oval in the middle there, at the top. Wakaroa, that's a Patterson's house with a 12-metre cantilever with terrain on top, which was a bit of fun, with a tolerance of about 5 millimetres on the end of the cantilever for glazing, which was a bit of fun. There's a couple of other houses there. I think that's Court Theatre, foundation pour, top left. There we've done quite a lot of strengthening work. That's the old municipal chambers in the centre. At the bottom, various other surf clubs, strengthening projects. The piano, which is in the entertainment precinct adjacent to the Court Theatre, that's on the bottom left. I'll talk about that a little bit more in a minute. A Feather from Afar, we do some sculptural work. That's in Shanghai, working with Neil Dawson, the sculptor. Big car park in Christchurch, 9 stories, I think. Jubilee Clock Tower, that's in Christchurch. That's a strengthening project. Win Williams House on the right. It was a hybrid LVL beam and base isolated LVL post-tension beams and concrete columns. Bit unusual. I think it was the first base isolated building to be built following the earthquakes in Christchurch. A few other sculptures and strengthening projects. We base isolated the Christchurch Art Gallery, which was a pretty intense job. There's a little bit more of the kind of things that we do. recently we did a bridge, which was a Glulam bridge in Christchurch over the Avon River, which is in the middle centre at the bottom. In terms of the mass timber and sustainability focus that we've more recently been involved with, this is a building at 211 High Street, which is a mass timber building with CLT floors, LVL frame, and Tectonus devices. Unfortunately, a lot of this has been covered up with glazing and enclosed for fire reasons, but this is when it was being built, and obviously you can see fairly extensive use of timber on this job. There's Cathedral Grammar, which is another CNC machined timber structure, which was another award winner. St Patrick's Church, which was all LVL, possibly some Glulam there. The bridge I was talking about is on the right. It's basically two Glulam girders going over the river, just been hoisted into place in the last couple of months. There you can see in the centre of this image, the Wynne Williams building with the post tension LVL meeting the concrete columns. More recently, well, in the last 5 years, Ruamoko started up a sister company called Ruamoko Innovation, which is a company that specialises in space and defence projects, predominantly working for offshore clients, mainly American. And the kind of work involves basically structural design of space infrastructure, ground-based, so launch pads, space radars and the like. The one on the left is in Naseby in New Zealand, which is pretty much the only project that Ruamoko Innovation has done in New Zealand. We've worked in all sorts of random locations on islands all over the world. That's one on the Azores, which is off Portugal. That larger picture is something we did for a radar system for the purposes of monitoring global warming on the top left. That's in Antarctica. And then Costa Rica, Perth, Hawaii. So that's been a bit of fun. We've picked up a few awards, and they include for the Court Theatre buildings, Court Theatre, as well as a bunch of other buildings. I'll try and wrap it up. History on the Performing Arts Precinct, where the Court Theatre is. We've done all the buildings basically in red. However, the Isaac Theatre Royal, that was done with one of our guys at Holmes Consulting Group in 2006. And we peer reviewed the Crown Plaza that Lewis Bradford worked on, but we've worked pretty extensively on the other projects. The bottom left is the Court Theatre project, and the larger one at the top right is the piano building, which I mentioned earlier. There's a few pictures of some of the projects on the precinct. Working on these projects gave us a really good idea of sort of what to expect in terms of ground conditions, contamination, geotech, and the like. The Court Theatre project is a project for the Christchurch City Council. They were the client, and was part of the strategic plan for post-quake Christchurch. Obviously, it's located on the Performing Arts Precinct. The Court Theatre are a theatre company, which I think is the largest professional theatre company in New Zealand. They were looking for an international quality theatre, something that's going to last for a long time. Hence, they did a bit of a journey around the globe to look at some of the best theatres of their kind, and they ended up getting the architects Haworth Tompkins, who are from the UK, involved as the architects, working with Athfields locally. Charcoal Blue, who are international theatre consultants, were involved as well, and drove a lot of the original design decisions. Originally it was a $24 million project, but that crept out to a $62 million project, which wasn't wasn't really engineering related. It was there was a lot of factors such as project prolongation, scope creep, and weirdly enough, the desire for more, not less. So rather than being VE'd, it was almost the other way around. Didn't originally have a fly tower and fly grid, which Thomas is going to talk about. That got put in later. From the get-go, it was made clear that relationships and people were going to be the key to the success of the project, and the project team was chosen on that basis, with early meetings and discussions, particularly around some of the local conditions and potential savings around foundations. There was quite a few contract wrangles in terms of the non-standard CCCS, which actually Ruamoko spent sort of a significant amount of money on the legal side of things, working to actually get a contract which was tenable, and that ultimately helped us in the long run because of the significant inflation and prolongation factors that I mentioned earlier. Yeah, working with Haworth Tompkins as an English-based architect had its challenges. They originally were talking about green roofs and rammed earth, and it was sort of a bit of a wrangle to explain the intricacies of some of the seismic issues that are present, obviously, in Christchurch in New Zealand. So that was obviously a bit of fun. And my role in particular was the concept design, the job procurement, having those early meetings, and basically wrangling the architect into coming up with something that was appropriate for New Zealand, basically. This is a bit of an example of something that I actually sketched up in MicroStrand as a bit of a joke, trying to explain that there were 5 levels of structure that proposed for the roof. Can we get it down to like 1, maybe 2, possibly 3? So I drew up the sketch to take to a meeting as a joke, to present to the QS to say, no, let's revisit it. He takes one look at it and said, oh, no, looks good, carry on. So that's just sort of sets the scene a wee bit. That's pretty unusual in the normal course of things. It has been a challenging project, mainly from a non-engineering perspective. There's been casualties in the client, the project teams, and a lot of people have found it fairly challenging, contractor as well. COVID, prolongation, funding issues, budget and scope increases, but highlights the importance of pitching in the jobs, tested people. When projects are running well, anyone can look good, but during a bit of adversity is when it really matters. And the measure of a good project is not just the awards won and being on time and budget, but can you still enjoy the journey and have a laugh afterwards, or a beer? And that's certainly been the case on this project, where we forged particularly strong relationships with the client, which was great. So yeah, it comes back to sort of the Ruamoko ethos of people, passion, and results, and it's led certainly to further work. So I'll hand you over now to Thomas, and he will take you through some of the more technical aspects.
Oh, thanks, Julian. So my half of the presentation will go into a bit more of the technical ins and outs of the job. Cool. So I'll start by giving a bit of a brief project overview. So the Court Theatre project covers approximately 4,000 metres of square metre covered floor area. That is split across 3 levels. The main auditorium seats approximately 380 people. There's also a studio black box theatre to the southwest corner, which seats another 150. The Court Theatre project has a full in-house workshop out back, so that's for set production. It also has multiple rehearsal spaces throughout the building. To the south, there's a 10-metre high atrium. And at front of house, there's a whole bunch of hospitality, so you have cafe, bar, and space for hosting functions. The consultants were led by Athfield Architects. They took over from Haworth Tompkins, who led the concept design, although Haworth Tompkins was still involved throughout the project in a limited capacity. Charcoal Blue were the main theatre consultants. Acoustics was driven by Marshall Day. PM was Octa. QS was ACOM. Cosgroves led the services side of things. PDP took over the geotech. Mott McDonald looked after the facade, which was largely a bespoke, not off-the-shelf product. Lewis Bradford undertook the structural peer review, and BG&E looked after kind of secondary structural supports for the facade. So moving on to some structural design parameters. The brief was for a 300 plus auditorium. So we'll straight to IL3. The relatively large building plan to height, tight SLS deflection requirements, and plenty of walls to make up the performance spaces kind of led us down the path of adopting a nominally ductile approach. The building didn't warrant any fancy time history or modal response analysis, so we adopted a standard 1170 equipment static to give us some sort of a gauge on the forces that we had to design for. At roof level, we're up to 1.3 G, right down to 0.3 G at level 1 or mezzanine. On the geotechnical front, the Arts Precinct generally has a consistent geology profile and a sound gravel bearing layer pretty close to the top. Geotechnical investigations undertaken identified medium dense gravels at about 1.5 to 2 metres depth across the site. And typical with a lot of sites in Christchurch within the CBD, the site was overlaid by uncontrolled fill from previous demolition. And no surprises, that fill tested positive for asbestos, and that all had to be trucked away and disposed of properly. Luckily, Ruamoko worked on the adjacent piano site, where a reinforced concrete slab over gravel raft was found to be the most cost-effective solution in that case. The Court Theatre actually has quite a similar building footprint and scale, so we opted to go down that same approach again. There was no need to reinvent the wheel. So the project brief required various building use cases to be accommodated and packaged into one building. These range from large open performance and rehearsal spaces, offices for the Court Theatre, full workshop, stage set construction, through to the hospitality side of things, including bar, cafe, and function space. Integrating diverse functionality posed quite a challenge structurally. A lot of the upfront effort involved working closely with the architect, ensuring that we could develop place structure to form robust low paths. And key to building, which is quite a piecemeal nature, having everything well tied together was high on the list of things to achieve. Ultimately, we settled upon having the main core of the building, which is the auditorium, formed up by precast walls around the outside, all tied together with a concrete floor that wrapped the full 360 degrees around the building. The internal precast walls that made up the auditorium space, they were 250 thick. That was driven by a combination of having enough density and material for acoustic requirements and needing some sufficient out of plane capacity for some of the taller panels in the auditorium space. I think some of those panels are getting about close to 40 tonne, if I can remember. The benefit of having the core and centering everything around that meant that we could develop, or having a robust core meant that we could free up some of the space around the outside of the building, and we could adopt some lighter structural elements such as the use of LVL, Glulam, and steel. There was a concerted effort by the design team to integrate as much timber elements as we could. The architect was very much trying to express the timber and not hide it away, and that included the steel connections. This choice of structural material was really a balance between accommodating the functional demands of the space. For example, in the auditorium, we had quite big spans carrying quite substantial theatrical lobes, so steel was best suited there. But around the outside, where we could rely upon LVL to support the lightweight roof, that was adopted. With some of with the heavy lifting or seismic lifting being done by the core, we were able to adopt a lot of large LVL timber members around the outside. I think the image on the right there gives a good showing of what we went with. So the blue being steel, grey being concrete, and the yellow being timber. You can see the blue tends to sit in the middle of the building, the grey, and then as you kind of work way around the outside of the building, you get a lot more timber elements. So at the ground floor, as mentioned earlier, we went ahead with a concrete raft slab over reinforced gravel raft. The slab sits at a constant level except for the main auditorium. It steps down approximately 500 mil. The same 600 mil thick slab is still maintained through this area, just step down. The finished floor level is actually 300 mils higher than the structural slab. We ended up going with a non-structural slab over top of polystyrene. And I say non-structural, but the slab was still designed to accommodate some of the lifting vehicles that the port required in the workshop space. The architect had various step floor levels. Initially, we were looking down the path of having multiple steps throughout the structural slab. However, to try to simplify construction, we adopted a one-step slab, and then we decided to go with forming the architectural steps with the non-structural polystyrene and concrete topping on top. This not only had significant advantages of making things simpler on site, but it also meant that a lot of the services could be accommodated within this non-structural slab. And it kind of avoided me having to arrive on site finding my rail cut to accommodate toilet pipe. So level one, I guess you could consider this more of a mezzanine. The mezzanine or level one wraps around the main core auditorium, the studio theatre to the west, or to the left-hand side of that picture, and wraps around the main atrium to the south. The primary function of this space was for hospitality and egress into the main auditorium and studio theatre. We had the luxury of being able to place steel beams where we wanted to through here, so that allowed us to adopt a lightweight floor. That also had the benefit of just reducing some of the seismic mass to the building as well. The floor was constructed from a mixture of LVL, standard SG8 floor joists, and CLT in the studio and main auditorium space. One big challenge here was the space available to fit structure. So the UK architect set us a floor height of 3 metres, which was really enough, and they got locked in pretty early. So we were forced to accommodate both structure and services for the most part in the same plane. This did lead us down to quite a lot of on-site consultation on the best approach to navigate both service and structure. what ended up happening is a lot of the services had to step around timber, and where that couldn't work, we adopted penetration through the timber joist, and then various strengthening methods were used, including screw strengthening, plywood strengthening, and off-the-shelf proprietary brackets. I certainly would recommend, if you're ever doing timber floor, just to make sure that there's enough floor depth there to have surfaces running at a different plane. It really does save everyone a lot of stress. So moving on to level 2. Level 2 is constructed from a combination of ribbon infill, double T's, and in-situ concrete. Level 2 is a mixed-use space, so it accommodates both rehearsal, function space, wardrobe, the court theatre's office, and just forms a bit of egress around the perimeter of the central atrium. The live loads for the rehearsal space, these were all driven by Charcoal Blue, the theatre consultant. I think they were in the ballpark about 5 kPa for a lot of them. Over the rehearsal space to the southwest, they required 4 kilonewton point loads to be hung from the floor for the studio theatre below. That, in combination with quite a large 11.5 metre span, meant that this was one area where we had to adopt double T's as opposed to the ribbon and pull. Most of the spans sit in that kind of 3 to 8 metre, which was perfect for the ribbon and pull. Just over that rehearsal space, we just had to go with something a bit more grunty. Along the east and south side, the floor actually narrows. We needed a pretty robust diaphragm through there and girt to restrain some of those heavy panels. So ultimately we went with the 250 thick in-situ concrete just to give it enough guts to provide that seismic restraint. Early in the design phase, we were looking at using timber concrete composite floors throughout this level, and they were intended to be supported on LVL beams. However, the workshop out back needed to maximise ceiling height to effectively be able to construct stage sets and then weld them into the main auditorium. We had some initial QS pricing at this stage, and we found that standard ribbon infill support on steel beams was significantly less than timber concrete composite floor system. So ultimately, that kind of helped us justify the decision to not go with that solution. The architect was pretty keen to try and minimise concrete, but by the time you considered that most of the volume of concrete is within the topping, that you weren't really increasing the concrete volume that much by swapping out the timber infills or timber joists for precast interspan. So at level 3, internally we refer to this as the trench level. This is effectively a plant deck level, much the same as level 1. This was constructed from LVL joists overlaid by ply. Again, similar intent to try to keep seismic mass down, especially at this level, being higher up. The joists break to make up the architect's roof balls. It did pose a bit of a challenge for the architect, given the length of it and needing internal downpipes. I don't think it was an easy thing to resolve on their front. Probably the biggest key driver for this level was, one, to have enough space to host the quite substantial ventilation systems and to conceal it from street view. Given the high aesthetic demand for such a building like the Court Theatre, the architects were very keen to not have big open ducts showing from below. The trench kind of solved that perfectly by being able to hide those ducts in between the roofs for the main auditorium and some of the outer spaces that sit around the perimeter of the building. So at roof level, the roof just adopts conventional DHS purlins, spanning over both LVL beams and timber steel pitch beam or pitch trusses over the main auditorium. Initially, the DHS was a late VE substitution for LVL. For the most part of the design, the roof was made up of LVL purlins, but again, it was quite a big significant cost saving had by swapping out LVL for conventional DHS purlins. The only timber purlins that remained were to the southwest corner, where the ceiling was exposed and the architect was keen to keep the timber visual element maintained in that space. Over top of the roof, we had a warm roof, and that was overlaid by a conventional metal profile, except for the south atrium. That was more of a bespoke roof, so that had DHS overlaid by stud framing, overlaid by warm roof, and then on top of that was 410. So moving to the front of house or south side of the building, the main atrium serves as the primary entrance and hospitality space. This space is largely formed up by 600 by 270 LVL beams supported on LVL columns. Given the lightweight nature of the roof, we were able to brace this along the southern wall with CBF LVL bracing. This effectively just braces the roof to the atrium and part of the level 1 mezzanine. A similar approach was continued through to the west side of the building. Again, we were able to support the lightweight roof with large LVL beams. These primary LVL beams were supported by LVL columns, and again, we just utilised the CBF LVL bracing along that west wall line. Unfortunately, the architect was also still keen to have all the bolted steel connections for the LVL Express, so we weren't having to fiddle around with concealed or plugging up steel connections, which was helpful on our side. The tricky part of the job, the main auditorium. Main auditorium is approximately about 280 metres squared. The stage that's positioned to the north end of the auditorium, and that consists of a demountable rostra for maximum flexibility for court theatre, and spills out onto kind of the seated area to bring the audience as close as possible to the production, to the show. The design brief to the architect was to create a close, intimate theatre, which put a big premium on space to fit structure and services. The extensive theatrical and operational requirements had to be integrated into the primary structure that encompassed 25 line sets, 6 independently moving crabbling beams which sat over the audience, and 4 suspended catwalks. Adding to the challenge was working with the theatre consultants, which was split between UK and Australia, just to add to the complexity of the job. To ensure the roof was designed fit for purpose, we realised pretty early on that it was key to have good and constant dialogue with the theatre consultants as they were driving the load demands in the space. We spent a lot of time making sure that we were interpreting their design requirements correctly, and that was followed through to construction. So the auditorium roof is supported by 3 flitch timber beam trusses and 1 steel truss, which kind of sits over the proscenium. The span here is approximately 18 metres. There was a strong desire from the architect to fill the roof space with deep timber trusses. This was to help aid in that attention to create a feel of intimacy in the theatre space and to provide that continuity of timber throughout the building. However, when we explored that option further, it quickly became apparent that going with an all timber truss wasn't going to be feasible, largely due to trying to connect a lot of large timber members and integrate it with both the steel structure and catwalks and the extensive theatrical equipment demands. So as a bit of a compromise, we worked through with the architect to adopt the fixed timber steel truss. A fixed truss was probably the most pragmatic solution here. It allowed for that continuity of timber through the auditorium space, which kept the architect happy. It also had a structural benefit of increasing the compression capacity of some of our cords. In this auditorium space, there are two levels or two tiered levels that wrap around three sides, along with seating in the middle. And if anyone's actually been to a show and found navigating seats to be tight in space and quite difficult, that was not a design flaw, that was intentional. So the idea being is you don't want to be too comfortable in your seat so that your full attention is paid to the show. The tiered seating around the outside, that was constructed from CLT and supported on steel. With the limited space through here, the key was to keep structure as thin as possible. Hence, that kind of led us down the path of CLT. It also meant that we could keep the seismic demands low here and not have to have big bracing through the space. As Julian mentioned earlier, there were multiple levels of bracing that needed to be accounted for. So the picture on the left, that's catwalk level. Picture in the middle, that is the plant deck level. And the picture on the right there is the roof level. Effectively, we had 5 levels and 3 levels of bracing plane, and that all needed a pretty robust and the direct blow path back to the primary bracing structure, which were the precast walls. Not only that, we also had to integrate the extensive and large amount of mechanical ducting through the space, catwalks, and the travelling beams, all just adding to the challenge. Yes, on the left, the catwalk level, that was braced back up to the level above. We utilised CHS members through the space to tie it all together. I couldn't find a good picture to demonstrate, but the space is extremely congested. Time you mixed in everything along with seismic restraint and the acoustic ceiling that sat just below the top quarter of the truss, things became pretty tough to fit. This is really where the digital modelling space really helps. A little extensive amount of modelling was done just prior to construction to ensure that we could fit everything together. To give a bit of context of some of the complexity we faced with structure within the auditorium roof, these are kind of our standard truss node connections. So the top row, these are the bottom chord of the truss. The bottom row, they are the top chord of the truss. In many instances, we had kind of 6 to 8 members all noding into one. Fortunately, we had a drafter that really enjoyed steel modelling, steel. So when it came to fabrication, the steel fabricator had quite an extensively worked through model that really did help in terms of when it came to construction. The roof kind of came together pretty seamlessly, and there wasn't there were no real major hiccups for installation. One thing we have to be careful of with these connections during fabrication is that the sequencing of how the steel members were welded together was pretty critical. We had to be careful of reviewing the shop drawings that the right members were welded first to ensure that there was the correct flow path through the joints that we were intending. Moving on to the construction side of things. So about mid-2022, Hawkins was awarded as the main contractor by Christchurch City Council. All the engineered timber that was manufactured in Rotorua by Restag Timber Lab. Steel fabrication was done here in Christchurch by VIP Steel, and precast done by Lean and Compt. To speed up construction, the gravel raft was constructed prior to consenting the superstructure. And that was probably done about a year, or almost a year before foundations started going into the ground. Construction started at the end of 2022, but really things kicked off at the start of 23. To Hawkins' credit on the job, they recognised pretty early on the complexity with such a build, and they took it upon themselves to lead a firm-first approach. This included extensive modelling of architecture, structural services, seismic restraint, and we had regular coordination workshops and through the use of Robusto for clash detection. And really ultimately paid off. I would struggle to see how this building would be built without first solving through issues in the digital space. The contractor adopted a measure twice, cut once approach. Hawkins engaged a third party, Offset Design, to lead a digital fabrication, manufacture and assembly process. This was to drive the CNC fabrication for the large LVL and Glulam members. The engineered timber interfaced across both steel and concrete. We had a lot of early discussions in terms of install sequence, and we made minor adjustments to connection details to suit prior to fabrication. This really helped on site, and things came together very smoothly. And kind of a testament to the hard upfront work and the whole digital coordination process. There wasn't a single mishap with the installation of the LVL members or engineered timber members. And in the words of the contractor, there was only one piece of LVL that required a wee gentle precision to get in place. Some other aspects of the job, there's quite a few in-situ joints that were required. By the time we accommodated door openings into the auditorium, the multiple mechanical ducts through precast, to reinstate viable lobe halves, split joints effectively were the most pragmatic and realistic way of doing that. It also aided with us keeping the panel sizes to something that could be transported to site without any kind of special vehicle pilot. A lot of the stitch joints were exposed internally, so the architect had these all sandblasted to get the design finish. Or that was a bit of a pain for the contractor to sandblast precast once in situ on site. No construction job ever goes without a few minor problems. The picture on the left there, that is a steel stub supporting a Glulam column, which is on the outside. Unfortunately, during the QA process, the galvanization of the steel stub was missed and it was just primed. And unfortunately, because the steel cleat is slotted through the middle of the Glulam and the underside of the base plate was not accessible, we had no option but to kind of cut this out. And then we ended up going down the path of reinstating it with the concrete plinth. It was quite congested, so we ended up having to use a few couplers to reconnect the threaded rod. But in my opinion, it probably looks a bit better as well, having a nice rectangular concrete stub as opposed to the steel stub that we originally had. Kind of hard to see it on the photo on the left, but there is a pizza oven Sounds easy, but if you position a pizza oven in the middle of the building, turns out it's quite hard to find space to duct it out to the outside. So effectively, the flue became a bit of a problem for this pizza oven. It had to work its way through all the structure, other services, through the auditorium roof and out one of the chimneys on the outside. For a project of this complexity, the core structure of the building came together, all things considered, pretty seamlessly without any true major complications. A large part of that was due to one, the proactive contractor, experienced foreman on site, and consultants' willingness to engage and be part of the construction process. All that played an enabling role to ensure a successful build. Thank you.
Oh, thank you so much, Julian and Thomas, for this wonderful presentation on the Cold Theater. I really enjoy when I walk around, and see the structure. I really pay a little bit of attention, It's a beautiful building to have around Christchurch. So congratulations on that. With that, we can start our Q&A session. We have some questions from the audience, so I encourage all our members that are still watching to present your questions. And I'm going to start with a couple that I have for you guys. And Julian, you mentioned that the client was hungry for more, and I guess that's quite atypical, right? Usually you try to cut costs or things that you want to do. So in general, how does that affect your design philosophy and your approach to solve problems? I guess it's a little bit different to what you usually do, or it kind of follows the same pattern?
It is a little bit different, but again, I think it's really highlights the idea of finding out what's important to the client. There's usually the default is that the client doesn't want to pay or wants to VE everything. But I think it's important, not just on this job, but on all jobs, to actually understand the driver. We're fortunate enough to work with a number of architects on high-end residential where they sort of say, how much is it going to cost to design a building on the edge of a cliff, say, with a 5-meter cantilever, and you say, well, the default might be, well, that's ridiculous, but when you actually run it through and say, hey, look, it might be another 1.5 million, or you draw it up and that's how much it is, and then they say, oh, that's fine, go ahead. It's sort of like, okay, well, that's a bit of a different approach. It wasn't quite to that extent on the Court Theatre, but it was, I guess, the difference between when we put the bid in for the job and at the end is I probably wasn't 100% glued up to the fact that they certainly wanted the international quality, I guess the rigorous services that they wanted in there. I was a bit, perhaps underestimated that. But in terms of how once I recognised that, it became a whole lot easier to make them aware. And I guess the exercise that I showed earlier, where I drew up the structure and sort of said, hey, look, I'm just going to present this. If you really want a roof with so much complexity, this is probably what it's going to look like. And then everyone ended up going in with eyes wide open. As long as they knew that was the case and they were happy to pay for it, then we were happy to draw it up. What we didn't want to do is draw something up and then have everyone say, oh, the roof's really complex. Why didn't you engineer it another way or do it a different way? It's like, well, you have that conversation early, and then everyone goes in eyes wide open. So yeah,
that's true, and it really helps, especially those early drawings, right? Like on a piece of paper, it really makes the difference when you talk with the clients.
Absolutely, and it's good to have those conversations early before you end up sort of in the detailed design phase. You just hash it out, bit of felt pen, and good communication with the QS, getting everyone in the same room, I think is really important for those type of conversations, so that everyone is nodding, and then it gets minuted, and then you can make a decision and go, rather than, I think, where projects can go wayward is where that the complexity doesn't get communicated, and then it only gets picked up during sort of the detailed design phase or through later stages, or worst case, when the thing's already going out for tender, and then it suddenly people become aware of, if we had have known that, we could have done it a different way, and then it's a problem for the client because they have to pay more, obviously, or potentially pay more. There's delays, and it's a problem for the engineer who has to not only rework it, but potentially rework it for no additional fees. So that nobody wins in that situation.
No, nobody wants that, for sure.
No.
On the same line of the question, then how was your peer review process? Did you have Lewis Bradford involved from the start, or did you have some pinch point? And if that's the case, how did you go through them?
We had Lewis Bradford were involved, and we've worked very closely with Lewis Bradford on peer reviewing. They've peer reviewed things for us and us for them. So we have a very good relationship. They became involved really early on, and we set some milestones as to what they needed to review and by when. And for the most part, it was pretty seamless, really. It was a good peer review process.
Oh, that's good. So no difference in the philosophy of how you were, facing the job, or how you want to progress with things.
We were very upfront with Lewis Bradford early on about what we were talking about before, about it being a fairly uncompromising. Not that it's the role of the peer reviewer anyway to sort of talk about VE or anything like that, but we had that conversation with them early so that they understood as well that yes, things are quite complex, but there's a reason why they're quite complex, and that's due to the uncompromising architecture, a lot of materials used, the layout, and those types of things, and they understood from an early stage, so that made the whole thing a lot easier.
That's good to hear.
Yeah. Again, communication is key. Yep.
Yeah. Now I have a question from Nick Calver. How did you design the mezzanine diaphragm forces? It looks like there are a lot of discontinuities and pinch areas.
I'll let you talk to that, Thomas.
Yep. So the diaphragm at the mezzanine level is all tied together with a ply diaphragm. Basically, everything's tied back to the core concrete structure, and a small part of it to the LVL bracing on the south wall. There was a lot of steel. It's not shown on the slides, but the diaphragm was all tied back with either steel beams or double ups or triple ups of LVL joists, effectively all just acting as ties back to the core structure.
Nice. And Martin Finney has another question. Can you please give a brief summary of how fire resistance was provided to the various parts of the structure? Example, exposed bolted timber connections, in-plane floor bracing, steel studs, roof trusses. Did this provide fire conditions, lateral stability to the concrete walls, etc.? So mainly a brief summary on how the fire resistance system works.
Yep. So fortunately for us, majority of the timber is only supporting the roof, so we didn't need to retain a fire rating there, so that helped out a lot. Really, probably the only areas that needed fire rating from the timber side of things were in that level 1 mezzanine. A lot of that was all hidden, the bolted connections within the architect's fire line ceiling. In terms of post-fire support, none of the timber was being relied upon for restraining any of those kind of precast or concrete elements. Similar to the roof trusses, again, they didn't have a fire rating requirement there, just being the roof and not forming part of any kind of egress pathway. Generally for the fire rating side of things, it was just a combination of intermescent paint to steel elements supporting the concrete floor, and anything that wasn't intermescent painted was covered up within the fire line. Also with
Originally,
the timber elements as well.
Originally, the desire was for TCC flooring, so timber concrete composite flooring, and that was getting pretty complex in terms of the fire protection. So we ended up, fortunately or unfortunately, the decision actually was driven by floor-to-floor heights. The TCC for some of those very large spans, I think they're in the order of 14 meters, was getting pretty deep to the point it was about 1.5 meters deep, and that was not. There was no appetite to pump the floor to floor up because there was a services requirement underneath for their sets and whatnot. So the decision was made for us and taken out of our hands. But for the majority of the concept phase, the floors were actually originally going to be TCC, which was a lot more complicated for the fire reasons.
Yeah. All right, thank you for that. I have another question from someone anonymous. You mentioned a few times that there was a lot of time spent up front that resulted in problems being solved early and effectively. How do we get this happening more across the industry so the build end of the project goes more smoothly and predictably? Noting that better finishes design should mean less RFIs and contract admin headaches on the way. So mainly, do you have any kind of input on how you can talk to the client or where all the parties involved so we can make this process more smooth?
I mean, that's the magic question, and I guess a huge part of that, as I've said, is communication. I think with the design team, we were fortunate on this project that the project manager and client made it really clear from the outset that the team was going to be, the project would be awarded to based on sort of people rather than just relying on the firm. And I think that's where engineers have a big role to step up in terms of fronting up to the client, the project team, and just talking through just being completely open about options and costs and structural implications. The earlier the better, because like I say, a difficult conversation at the front end, whilst uncomfortable, is nowhere near as uncomfortable as it is when it's at the back end of the project. That's when real problems can occur. So I sort of like to see it as a little bit of pain up front, saves a whole lot of pain at the end. And I think if you're playing the long game, and our firm's been around 20 years now, you really want to make sure that I think you win in the end by delivering some bad news if you need to early on. Perhaps this might not be affordable, or here are the implications, but as long as you take the people on the journey, that they pretty much, and give them enough information so that they can make the decision, rather than saying it can't be done or we think it's a bad idea. As long as you give them the information and the reasons for and against, or the implications, then it doesn't necessarily need to be the engineer giving the bad news. It can be just the engineer providing the information, and they can choose one way or the other.
Yeah, it's more to have that conversation, right, instead of imposing rules to the clients.
Exactly, and not being sort of scared of having those early conversations when the news may not be what the client necessarily wants to hear. But like I say, better to have it earlier than later. Yeah. But it is tricky. Every client's different. On this job, the client was particularly good communicator. But yeah, pretty much my advice.
Yeah. And one last question for today from Daniel Moroder. Did you have any issues with water and moisture ingress during construction? And what was your moisture management strategy?
Do you want to talk about that,
Yep.
Thomas?
So the large LVL and water members, they arrived to site with a sealant applied to it. So I think that was good for about 6 months to a year. We did strike one issue with the plant deck before, so the structural ply that was left out in the rain to the elements for too long, and we ended up having to rip that out and replace that. But that was the really only issue that we struck in terms of moisture management for the timber elements. We're quite lucky as well that the builder made good progress, and a lot of the exposed LVL and timber members were covered up pretty quick.
All right. So basically, on the moisture management strategy is what the manufacturer of the timber, in this case, Red Stagger, is that right? They provided some form of managing the moisture inside, or was more something that you had to specify directly?
Yeah, so Red Stag had I guess a sealant coat applied to it. I think the key with these timber buildings is just to minimize exposure time. So really trying to keep the time that the timber elements exposed to the weather is pretty key.
And when the structure was enclosed, did you manage to measure the moisture after? So just to make sure that the moisture was to the right levels?
No, so we didn't go through a measure for the moisture meter.
Right. It's just waiting for it to dry up, I guess.
Yeah, we have done that more recently on. Fortunately, the roof was put on in short order. However, the building I showed you earlier, 211 High Street, we did in fact go through with a moisture meter just to check things because it was out exposed for so long.
Yeah. Yeah, I think I heard that from that 211 High Street. That's why I was asking you.
Yeah.
Yeah, it's more like the up-to-date way of doing it, right?
Yeah, it was just a more exposed, and in some cases there was sort of ponding water, and there was on that project there was CLT flooring, so no concrete topping.
Yeah, right. Well, awesome. Thanks, Julian and Thomas, and thank you everyone for joining in and being part of this session. And on behalf of CSOC, I wish you a Merry Christmas break, and hopefully we see you in the next year. See you guys. Thank you.
Thank you.